titled, What Do I Know About the Roots? And the subtitle is More Real and Complex Roots. The learning objective is to explore the connections among the roots, the equations, and the graphs of the polynomial functions. Okay, so question number 72 says, based on the following graphs, how many real roots does each polynomial function have? Justify your reasoning and explain how you know these are real roots. For part A, we have that parabola. That first parabola is crossing the x-axis. Looks like -1 and +5. So it has two real roots. It crosses the x-axis 2 times. Okay? That's pretty self-explanatory. B. This one crosses here, here, and here. So it has 3 real roots. It crosses the x-axis 3 times. It says the graphs of A and B have been shifted vertically to create graphs C and D below. How many real roots do the graphs of C and D have? C takes that parabola from A, moves it up, and now, because we've moved that vertex, it's not crossing that x-axis at all. So that one is going to have 0 real roots. D, we take it and we shift it up. Right here, it's not going to even bounce off that x-axis. It's just not even going to come down to it. But we still have it crossing in one spot right there. So it ends up having 1 real root. Okay. Then down at the bottom, for part E, it says, do the polynomials in parts C and D have fewer roots than the corresponding polynomials in parts A and B? They're still going to have roots. They're just going to be complex. Okay, so like we saw with completing the square and the quadratic formula, you're going to get that plus or minus I in your answer. Okay, that shifts it up above the x-axis, so it's not going to cross it. Okay, for F, they want you to sketch the graph of x minus 2 quantity squared. What are the roots? There are 2 real roots. It bounces off the x-axis. It technically is a double, right? Because it would be x minus 2 and x minus 2. Three says, recall that the graph of a polynomial function with degrees n intersects the x-axis at most n times. For example, consider the 3 graphs below. Okay, so for the first one, state the number of times it intersects the x-axis. This one intersects the x-axis once. It's technically a double, right? Because of the x plus 1 squared. This is technically x plus 1 and x plus 1. The second one, x squared plus 1, intersects at exactly 0 times because it's floating up above the x-axis. And the last one obviously intersects it twice. X squared minus 1 would factor to x plus 1 and x minus 1. All right, question A says, how many times can a polynomial of degree 3 intersect the x-axis? Make a sketch of each possibility. Okay? So if we have a polynomial with a 3rd degree, that means it needs to have 3 directions. So on the first one, I showed it intersecting 1 time. So we have 1, 2, 3. 3 directions, but it only crosses the x-axis once. The second one still has 3 directions, 1, 2, 3 directions. It crosses once here and bounces off here, so it touches the x-axis twice. Technically a double at, let's say this is at 3, 0. Okay. And the third one, obviously 3 directions. Crosses once here, crosses once there, crosses once there. So those are your 3 options for a third degree polynomial. Part B says, can a third degree polynomial have no real roots? Explain why or why not. The answer would be no, a polynomial of third degree, because of its shape, it has to have those 3 directions. It's gonna, one of the tails, either the end tail or the beginning tail, is gonna have to cross that x-axis at some point, at least once, okay? All right, question number 74 says, now consider the polynomial y equals x cubed minus 2x squared plus 3x minus 2. How many real roots could this polynomial have? Well, we just saw that it could have 1, 2, or 3, right? But we don't know. So they're going to give us a little bit of information about it. And they're going to tell us that x cubed minus 3x squared plus 3x minus 2 is equal to the binomial x minus 2 times the polynomial x squared minus x plus 1. Where'd they get that from? Okay. Well, if you work backwards and you take the x minus 2 and you multiply it by the x squared minus x plus 1, here's using the box method. You would multiply the term up top with the term on the left. So x squared times x would get you x cubed. X squared times negative 2 would get you negative 2x squared. And then you would double check to make sure by combining like terms that it was equal that full long polynomial. Okay? So these two combine to get the negative 3x squared that's right there. These two combine to get the 3x that's right there. And then obviously this lone guy is the minus 2. Okay? Then we ask down at the bottom, can it be factored further? The answer is technically yes, because you could use. All right, so at the top of the page 21, we're going to take that same polynomial, and they want us to, using the right side of the equation, solve for all the roots of the x cubed minus 2x squared plus 3x. This is the same one we just saw on the last page, right? They already gave us the x minus 2. That one's easy to solve for. You just add 2 to both sides and you get x equals 2. The other one, we said it was not easily factorable. And the only way we could do it, technically you could use completing the square. I'm just going to use the quadratic formula on it, right? So in front of that x squared, there's a 1 that you can't see. In front of the x, there's a negative 1. And our constant term is 1. You're going to take those 3 numbers and plug it into the quadratic formula. It looks like this. X is equal to negative b. Plug in the negative 1. Plus or minus the square root of b squared, which is negative 1, minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 1. A lot of 1s. I guess that's good. It's easy to multiply by 1, right? On the next pass, we're going to simplify. So the opposite of negative 1 is positive 1. Rewrite the plus minus. Rewrite the square root. And the negative 1 squared is 1. And then negative 4 times 1 is negative 4. So 1 minus 4 is negative 3. going to pull out that negative to get our I. And then 3 is not a perfect square, so it doesn't simplify anymore. Okay? So if we have an answer right here, we have 1 plus or minus I rad 3 over 2. And that's part of a third degree polynomial. This is the part where it's not going to intersect the x-axis. This is the part that will. Does that make sense? Will touch the x-axis, won't touch the x-axis. Okay? So question D asks, how many x-intercepts does the graph of that polynomial have? How many real roots? And how many complex roots? Okay, so this one has one x-intercept, which is one real root, and then it's going to have 2 complex roots. That's going to be the part floating up above the x-axis. So you can kind of picture it in your head of the graphs that we drew rough sketches of. It would be the first one on the left, where it crossed the x-axis, and then it had a little hump and goes up to positive infinity. Okay? All right. Last little bit here. So for question number 75, I'm going to do A and B with you, and then in your groups of 4, you're going to do C and D. It says for each polynomial function below, determine all of the roots and describe them completely and sketch a graph. Oh, I didn't sketch graph. Okay, we'll have to sketch graph. Okay, so for A, we have x times the x squared plus x minus 1. That x part is easy. Just set it equal to 0. It's going to cross the x-axis at 0. Nice and easy. Then for the second part of it, it's not easily factorable. There isn't something that multiplies to get -1 or adds and subtracts to get +1. It just doesn't work out. So we're going to use the quadratic formula on just this part of it. Not that, because that's already done here. Okay? So in front of that x squared is a 1. That becomes our A. In front of the x is a 1. That becomes our B. And our constant term is -1. So we're going to plug and chug those numbers into the quadratic formula, which is x is equal to -b plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 1. Again, a lot of 1s. Then we take the next pass and we simplify. We rewrite that as -1, rewrite the plus minus, rewrite the square root, and then we simplify under that radical. So 1 squared is 1. Then we have -4 times 1 times -1, which ends up being +4, all over 2. We actually end up with a positive under that radical, which means no I ends up in there. There's no I. So we're actually going to get decimals. -1 plus the square root of 5 divided by 2 is this first decimal of 0.62. And -1 minus the square root of 5 over 2 is -1.62. So that's going to be 3 real roots because we didn't end up with any i's in our answer. Okay? So that one's going to cross the x-axis 3 times. So if we did a rough sketch, here's your x-axis. It's going to cross, obviously, at 0. It's going to cross at 0.62, so really close to it, and -1.62, so over here. And it's positive, so we should end up. So it's going to go like that one. All right. Obviously, that's a rough sketch. If you were to actually plug it into Desmos, it would probably be stretched a little more. Okay.